take a look at an example. Consider 3-point charges, Q1, 6 microcoulombs located at 0, 0, Q2, negative 2 microcoulombs located at 0, 3 meters, and Q3, 5 microcoulombs located at 4 meters, 3 meters. Find the resultant force, magnitude, and direction on Q3. This problem is on the coordinate plane, and more specifically, it's in the first quadrant of the coordinate plane. They say that Q1 is located at 0, 0, and it's 6 microcoulombs. So that's the origin. I'm going to label it. 6 microcoulombs is the same thing as 6 times 10 to the negative 6 coulombs. Next, Q2 is negative 2 microcoulombs located at 0, 3. That's over 0 and up 3 meters. Here's Q2, negative 2 microcoulombs. And finally, Q3, 5 microcoulombs located at 4, 3. That's over 4, up 3. Here's Q3, 5 microcoulombs. And what I have here is a triangle. It's a right triangle, and in particular, it's a 3, 4, 5 right triangle that I recognize from geometry. There's my right angle. I'm going to make some assumptions about this problem. I'm going to assume that the charges are stationary. In other words, they're being held in place. If the charges were free to move, if they were floating in outer space, the problem would become much, much, much more complex. So we're just going to find the forces on Q3 in that first instant, or while the charges are stationary. Okay, so a couple of other things. I know that charges that are like repel and charges that are unlike attract. So I'm going to focus on Q3, and I'm going to realize that Q1 and Q3 are like charges, so we're going to have a repelling force up and to the right. I know that this is a 37-degree angle, again from geometry, which means I know that that first force vector between Q1 and Q3 is at 37 degrees. What I don't know is I don't know the length of that force vector. And I am going to compute it. So the force between charge 1 and charge 3, I can calculate using Coulomb's law. So K is 9 times 10 to the 9th. Q1 is 6 microcoulombs. That's 6 times 10 to the negative 6th. Q3 is 5 microcoulombs. That's 5 times 10 to the negative 6th. And that distance then is 5 meters, and that's squared. And when I compute that value, I get 1.08 times 10 to the negative 20th newtons. And again, that's the magnitude of that force, and it's at an angle of 37 degrees. Next, I'm going to focus on the force between Q2 and Q3. Now, Q3 is attracted to Q2 because they have opposite signs, and I can see that the angle here is 180 degrees, and I need to use Coulomb's law again to compute the force between charge 2 and charge 3. So I'll use Coulomb's law. Again, K, 9 times 10 to the 9th. Q2 is negative 2 times 10 to the negative 6th. Q3, 5 times 10 to the negative 6th. And that distance then is 4. And when I compute that value, I get negative 0.0108, and that is at 37 degrees. Now what I'm going to do is focus on the force between Q3 and Q2. Q3 is attracted to Q2, so that angle is at 180 degrees. I'll be using Coulomb's law again. K is 9 times 10 to the 9th. Q2 is -2 times 10 to the -6. Q3 is 5 times 10 to the -6. And my distance then is 4 squared on the bottom. And when I multiply that out, I get -0.005625, which could indicate that that is to the left. Or you could think of it this way: a negative indicates an attractive force. But really, when I write out my what my force actually is, I'm going to write it in polar form, which is 0.005625 at 180 degrees. Okay, now I'm ready to add my vectors together. And what I'm going to need to do next is resolve each vector into its components. So, let's see what we've got here. Punch those in, and I get 0.0086 and 0.0065. Now for my other vector, it's all x. It's a horizontal vector, so the horizontal or x component is just going to be -0.005625, and the vertical component is 0. My next step is to sum the x and y components. So 0.0086 plus -0.005625. And then for my y's, 0.0065 and 0. That one's relatively easy. And my top value, 0.0086 minus 0.005625, is 0.002975. Okay, now remember what this represents are the x and y coordinates and of a vector, and I need to convert this into a r and a theta. So I'm going to sketch the coordinate plane again, and here's my x, 0.002975, and here's my y, 0.0065. And the resultant that I'm looking for gets me to the same place, but in terms of r and theta. And I can solve for r with the Pythagorean theorem. R squared would equal 0.002975 squared plus 0.0065 squared. So after doing that calculation, my r value is 0.0071. And then I do inverse tangent to find my angle, and when I do inverse tangent, I would get an angle of 65.4 degrees.